Hello everyone, welcome back to my channel. In today's session, we will be learning another important algorithm for sorting, that is bubble sort. So let us go ahead and see what is a bubble sort, how does it work, and how does it help us to sort a given array of elements. So a bubble sort is a fundamental comparison-based sorting algorithm, like how we have seen in the previous example where we did a selection sort. There also we did a comparison of elements. So this bubble sort is also a comparison-based sorting algorithm. So let us see step by step how it works. So what is the challenge and what is the problem description? So for example, given an unsorted array of n elements, the objective is to arrange them in a specific order, typically ascending or descending. Bubble sort addresses this by repeatedly stepping through the list, comparing the adjacent elements and swapping them if they are in the wrong order. This process is repeated until no swaps are needed, indicating a sorted array. So what we're going to do is, given an array, we are going to compare the adjacent elements until we are going to get a sorted element. So the moment we find out that adjacent element is greater than or lesser than, then we are going to simply swap it. Now, it is not as simple as that. There is a different methodology we use, because in the selection sort also we use the same kind of a methodology where we'll compare and swap. Now let us see how does the bubble sorting work. So there is something called as a first pass, second pass, third pass, etc. And this pass will terminate only once we have a sorted array. So as you can see in the first pass itself, we have a set of loops which is going on. In the second pass also, we have a set of iterations which is going on. And in the third pass also, we have a set of iterations going on. So let us see. So given an example, if this is an unordered array given, how does a bubble sort works is, it is going to first take the first element and second element and it is going to compare. As it is very clear that the right hand side element is smaller than the left hand side, hence we are going to swap it. Okay. So once I swap that, what I'm going to get is the 1 is going to come over here and 5 is going to come over here and 4, 2, etc. we are going to get. I will not stop here. This pass will continue by swapping the next two elements. Now I'm done with the first one. Now I'm comparing this, but this is in the same order. Hence there is okay, yeah. So 4 is lesser than 5, hence I'm going to swap. As you can see, 4 is come here and 5 is here. Next, I'm going to swap the next two elements. And as you can see, once again, 2 and 5 need to be changed. And then when I come here, I need not change. But once again, I'm going to iterate and see if there is any swap required. Hence, I will stop. Okay. So as you can see here, in the completion of the first pass, what is the change happening here is we have the biggest element bubbled down to the bottom of the array. So hence the name bubble sort. Bubble sort is called in this way because after the completion of each pass, the largest element will settle down at the bottom of the array or bubble down and come down to the bottom. Okay. So if you see the next pass, so I'm not going to touch this one. Now this is reached its correct position. Now I am only concerned about the next. Okay. So I'm going to compare the first two. As you can see, it is in a correct position. Hence, I'm not going to swap. I'm going to compare these two, but this requires swap. Hence, 2 comes over here, 4 comes over here. Next, I will compare 4 and 5. This is in a correct position. Hence, no swapping. Once again, I'm going to check 5 and 8. No swapping is required. Now, as you can see, after 8, 5 was the biggest element and it has reached its correct position. Next, we will be focusing on the third biggest element, which is nothing but the 4. So when I come here, as you can see, there is no swap required. Next, I'm going to compare these two, no swap required. Next, I will compare these two, no swap required and no swap required, which means whenever we come across a pass where there is no swap happened, that will become my termination condition. So I can terminate from the algorithm, which means that I have got a completely sorted array. All right. So this is how a bubble sort works. I hope it is clear. Slightly different from what we learned in the last class, which is selection sort, where we would select the minimum and then swap. Here it is comparison of the adjacent at every pass, and every pass will have multiple iterations. All right. So if at all we have to discuss, if at all we have to tell briefly the working, first is we will have a first iteration where we will compare the adjacent elements from the beginning, swap if the left element is greater than the right, and the largest element bubbles to the end. And subsequent passes, repeat the comparison and swap the process for the remaining unsorted portion. Remember, with each pass, the next largest element moved to its correct position. And the termination condition is the algorithm terminates when the entire pass completes without any swaps, signifying that the array is fully sorted. Then we can go ahead and terminate our algorithm. All right, so this is how it works. So let us see the pseudo code. So bubble sort algorithm. The core logic of bubble sort involves nested loops. Okay, as we can see, it is a nested loop because we need to have passes, and inside the pass we need to have number of iterations. The outer loop controls the number of passes. So this particular one will tell us the number of the passes we are going through, while the inner loop performs the comparison and swaps. This is for your comparison and swaps. Okay, so if I have to consider the previous example itself, so I had 5, 1, 4, 2, and 8. Let me write it. Okay. So let us see, n is equal to length of my array. So when n is nothing but how many number of elements I have, which is nothing but 5. For I is equal to in range, our range n minus 1. So this is in Python. So I in range n minus 1 is nothing but you can consider a for loop which is starting from, in our case, if it is range is starting from 0, we can simply say that from 0. If I'm numbering it as 0, 1, 2, 3, okay. From 1, 0 to n minus 1, which is nothing but 4. This is my outer loop, and I'm going to take another loop where j is equal to, j is going to start once again from 0 to, now remember this is n minus I minus 1. So n is nothing but 5 minus I as of now 0 minus 1. So this value is going to change every time. Now why so? Now see here carefully. When I is equal to 0 means this value is simply going to be 0 to n. Okay, 0 to n means I am going to compare all of them. This is for the first pass. Now, once we complete the first pass, we know that this particular last element will be in its correct position. I need not go till there, which means once I complete the jth loop, when I value increments to 1, next I am going to iterate j from 0 to 5 minus 1 minus 1, which is nothing but 4, which means I have to only, 5 minus 1 minus 1 is nothing but 3, which means I need to go only from 0 to 3. That is for my second pass. Okay. Similarly, once I complete comparison and swapping of this, j loop will become false, and then we will go to the outer loop. Going to the outer loop is nothing but I will increment the I value to 2. Then that is nothing but the beginning of the third phase. So that time the j value is going to start from 0 to 5 minus 2 minus 1, which is nothing but 3, which means I have to iterate the j loop from 0 to 3, which means, this is not 3, 0 to 2. 5 minus 3 is 2, so which means it is a third pass. I need to only see over here, which means in the second pass, this position would have occupied by a correct value. Similarly, when I value increments to 3, which is nothing but the fourth pass, j value need to go from 0 to 5 minus 3 minus 1, which is nothing but 0 to, this will be 1. So which means I need to focus only over here, which means this would have reached the correct position. And for the fifth one, we need to go from 0 to 5 minus 4 minus 1, which is nothing but 0, which means I'll have a remaining only one element. So that is why we say that this particular loop is for the phase, number of phases, and this is only for swapping. Okay, this is about the outer loop. Now next, let us talk about the inner loop. How does it work? Let me once again write this. Okay, let us take n is equals to 5. I will execute 1 as an iterate 1 value and see. So I is equal to 0 to 4. j is equals to also 0 to 4 initially. Now I'm saying if array of j, which is nothing but here, if array of j is greater than array of j plus 1, j plus 1 is this one. Yes, in this case, this is greater. So I need to swap. So what I'm going to do is my array of j comma my array of j plus 1 is equal to my array of j plus 1 comma my array of j, which is nothing but it is a simple swap instruction in Python. So after the completion of this, it will be in this way. All right. So next what is going to happen is j value is going to get incremented to 1. So which means now j is over here and this is my j plus 1. Once again, I'm going to compare whether this is greater than this. Yes, in this case, hence I'm going to swap the value. When j value becomes greater than j plus 1, as you can see, if array of j is greater than j plus 1, I'm going to swap it. So this is going to become in this way. All right. Okay. Now, once again, I'm going to increase the j value to 2. 2 is over here. So now this is the, hence this will become j plus 1. Once again, compare. Yes, j is greater than j plus 1. Then swap. 1, 4, 2, 5, 8. All right. Once again, increment the j value. J value is now 3. And then hence this is j and this is j plus 1. Compare. No, there is no change required. Hence increment the j value to 4. When the j value becomes 4, we need not. We will stop there. The condition become false. Hence we will go back to the outer loop, which is I. Now I will become 1. When I will become 1, once again we are entering the j loop. We will start from 0 to now 3. Okay. So once again, 0 to 3, we will apply that on this one. So we will start from j will be over here. This will be j plus 1. We will compare whether these two are greater. And then when this is not, hence we will move on to j is equals to 2 and it will continue. I hope it is clear. So this is how the relation between for loop I and for loop j is. I hope it is clear. So as you can see, this is same example. Initially, in this is the pass 1 where your I value is 0 and j value is 0 to 4. So that time what we are going to do is we will compare as this is the first iteration when j is equal to 0. This is j and this is j plus 1. Okay, and then swap is going to happen and then j value will increase. For this j value is over here, hence j is here and j plus 1 is here. We are going to compare and then swap. When j value is 2, that is over here, this and this is j, this is j plus 1. We are going to compare and then we are going to swap. And j is equal to 3, that is 0, 1, 2, 3, this and this, there is no swap. And then j value, which was 1, will be j value becomes 4 and it will terminate and I value will become now 1. So when I value becomes 1, j will iterate from 0 to 3. That is why 3 iteration here. So when j is 0, this is the j and this is j plus 1. There is no swap. When j becomes 1, this is j and this is j plus 1 and then we will swap it. When j becomes 2, this will be 0, 1, 2, these two. As in we are going to compare and there is no swap. And since it is going to next j will increment and it will become 3, j value will become false and then I value will get incremented to 2 and j will start from 0 to 2. That's why only 2 iteration. So when j is 0, we are going to compare these two, no swap, and j is equal to 1, we are going to compare these two and there is no swap. So as you can see, it's a entire iteration, there was no swap, hence we will say that the termination condition satisfies and also I will become 3, which is once again it fails the loop. Hence we will terminate this algorithm and we have our sorted array. All right. So this is how a bubble sort works. So if you have to discuss about the time complexity, so in the best case, it is order of n. The best case arises only when array is already sorted. That is only n times we are going to iterate and see that whether there is any swap is required. And if there is no swap required, that we understood that the array is sorted. Average case and worst case is always order of n square. Now, why order of n square is, as we can see that there are two loops, nested loops, and whenever you have a two nested loops, it is always order of n square. So be it whether an average case or a worst case, you have to have all those many number of phases and then those many number of iterations. There is no other option. Hence, both the cases, it is going to remain same. Okay, so best case is order of n and average case is order of n square and worst case is also order of n square. So what is the key takeaway? It is simplicity and its efficiency. Bubble sort is simple to understand and implement, making it ideal for teaching basic sorting concept. However, order of n square time complexity makes it inefficient for large data set, like how we have seen in the selection sort. So practical applications rarely used in production for large-scale sorting due to the performance, useful for small arrays as a pedagogical tool, that is to teach in introductory programming courses, and exploring alternatives for more efficient sorting. Consider algorithm like merge sort, quick sort, or a heap sort, which we are going to learn in the coming sessions, which offer better average and worst cases. Okay. So compared to those, bubble sort is not that efficient. All right, so that's all in today's session, students. Hope this has been helpful. If there is any doubts, kindly comment in the comment box and I will try to answer your queries. So thank you for watching. Keep learning.